So we are back at it again. Today we'll be doing our A-level paper 11 from May-June 2021. So without further ado, let's get started with our question here. So our first question is actually regarding identify the equation of a curve. So for this, clearly we are required to use integration to do so. So the first step that I'm writing down will be y equals to integration 3x to the power of negative 4 plus 32x to the power of 3. So you should notice that I actually make some adjustment to what we have here. Okay, because if I leave it as a fraction, I can't really solve it. Okay. So from this, you actually know your outcome as negative x negative 3 plus 8x 4. So if I were to put it like this, you won't understand all the details. And then, so in order to help you with your understanding, I'll be explaining this at the side. For those who understand, you can go ahead and keep on with your solution here. Okay, so try to explain it as detailed as possible. So this 3x to the power of negative 4 here. Okay, let me write it at the side. Okay, I would treat it as my dy dx. And then when we try to revert the effect of differentiation, the x, okay, the power of it will actually increase by 1. So if negative 4 increased by 1, you actually get negative 3. And just put a unknown at the front and you can proceed with the next step, which is to differentiate what you have here. Okay, you actually get negative 3 unknown, x negative 4. So when you compare it accordingly, then you will get your results as negative 3 unknown equals to 3. Unknown will be negative 1. So for me on the side, I only included negative because you don't actually have to mention that it is negative 1. Okay, negative itself already represented it. As for the other one on the side, maybe I'll write it in red. So for this, same thing, repeat the same step. Your dy dx is actually 32x cubed. Your y would be unknown, x. When you increase the power by 1, it will be 4. Differentiate it, and you will get to your results of 4 unknown x cubed. Compare them accordingly. Then you will have 4 unknown equals to 32. Unknown will be 8. So just like this, okay, it is how I identify that it was 8 here. But after a while, if you practice enough, you will know all the details immediately. You don't have to do such details working on the side. So from here, the next thing, you will notice that I included a constant here, a c. The reason why I do so is because I noticed they gave us the coordinates. So you're required to substitute in the coordinates that we have here. Okay, so when I put it in, this is what I get. Properly. So to identify your C, it will be 4 plus this minus all of the details here. Then you will get to your final answer. So let me run the calculation. Okay, you will get your final answer as 23 over 2 or 11.5, and your entire calculation will goes by y equals to negative x negative 3 plus 8x4 plus, depends on whether you want to write it in fraction or not, For me, I will leave it as 11.5, and if you were to further rearrange this equation here, this would be your final results. Okay, so that's how you secure the first 4 marks here. Moving on, we have our question 2 that goes by our arithmetic progression. Okay, so I will try to include the formula somewhere around here. Okay, and then the keyword here is the first 20 and the sum of the first 40. Okay, so these are the things that I will pay attention to. So we are using sums formula. So your S20 is actually okay, and this answer here, after you rearrange it, you will actually get to this, and they are equals to 405. So this was the first equation that I identified, and based on the next one that they gave us, they said that S40 is actually 1410. So let me fill up the details accordingly. Okay, so I actually have a 20, 2a plus 39d equals to 1, 4, and 10. Okay, so this will be your equation 2. Okay, so if I were you, I won't stop here. I will further simplify this entire thing and get to 2a plus 19d equals to 40.5 because I shift the 10 to the back. Same goes to this, you have 2a plus 39d equals to 1410 divided by 20. So you get 70.5 here. Then only updated this as my 1 and this as my 2. You can use your elimination method that you learned back then in your mathematics, and then you will have a 20d. Okay, just in case you can't catch up with me, I write it in details here. Minus off with 2a plus 19d. So you will get to your final answers of 20d and also this is a 30. So d of this will be 3 over 2. Just in case you don't know what happened here, the negative will be multiplied into the two variables inside the brackets. Furthermore, we still have to find our a here. That is not done yet. So 2a plus 19d okay, equals to 40.5. A is actually 12 and a will be 6. So with these two answers here, we can now fulfill and find the 60th progression. Okay, this is sum of the 60th term, but are they looking for it? No, they're actually looking for the 60th term. Okay, so to get to the answer, you actually have to do U60 instead. U60, you will get it by using the formula again. The formula goes by a plus 59d 6 plus 59 times 3 over 2 . Okay, you will get your final answers as 94.5. So this is how you secure the 5 marks here. Okay, remember this is not what they want. Okay, don't get confused by it. Moving on, we have our question 3 here. They want you to expand this into the first 3 terms. Okay, they want us to use binomial expansion formula. So for this, you actually have to follow the formulas that goes by 3 to the power of 5, adding up with 5c1, 3 to the power of 4, negative 2x, and also followed by 5c2, 3 to the power of 3 and negative 2x squared. So when you expand this accordingly, 3 to the power of 5 is actually 243, followed by 5c1 times 3 to the power of 4 times negative 2, you will get your results as 810. And lastly, we have 5c2, 3 to the power of 3, and then 4 here. It will be 1080x squared. Okay, this is how you get it done. Okay, quite straightforward. 3 marks for this. Find the x squared here. So the only difference or the things that didn't appear from the top will be this. So which clearly we are required to expand that. Okay, as for the one at the back, it's actually repeating from the top. So as I expand the brackets, you actually get 16 plus 8x plus x squared, and also our 243 minus 810x plus 1080x squared. You have to find the correct combination that multiply together and get to x squared here. So we actually have our 16 paired up with this. Okay, other than that, we have our 8x multiplied with negative 810. Then lastly, we have our x squared against 243. Okay, so when you run your calculation accordingly, remember coefficient is referring to the numbers at the front. So when we run out our final calculation, so 1080 times 16, you actually have 17280x squared minus this off with 8 times 810, you will have 6480x squared, and then plus 243x squared for the last one. So when you calculate this accordingly, you actually have 11,043. So for this, it's actually x squared. So I will write a conclusion at the side and says that coefficients of x squared is 11043. Okay, that's how you secure the 3 marks here. Okay, moving on, we have our tangent graph. Okay, interesting. So a couple of things that I noticed was that the entire graph actually starts from here. Okay. Okay, I'm not sure whether you learned maths back then, but this is the vertical translation. So the vertical translation will be replacing the C here. So the first results that I identified was actually for the C. So once we identified C, the next thing that we're gonna do will be the B over there. The X minus B actually represent whether the graph was being shifted to the left or right. Okay, so clearly the graph was being shifted to the right hand side. Okay, by how much? You can actually identify it by looking over here. So the graph was supposed to start from this point if it's only vertical translated, but since then it was being transferred to here. So from this you will know that your b's value, okay, is actually pi over 4, or if you want to write it, you can write it as 1 over 4 pi, up to you. So now that we have all the necessary information, one last step, which is to identify our a there. Okay, so the a is actually, so let's say I want to identify my a. What can I do here? Okay, maybe I choose this as the point for me to run the substitution. It is actually pi and -1. So let's say I sub it into the current equation that we have here. Okay, so when I put in my y, it was -1, my a is still the unknown that I'm trying to find here, my x is now pi, and then let's see whether we can get the results. So it's actually -2 divided by tangent pi minus pi over 4 equals to our a here. So -2 divided by tangent pi minus pi over 4. Okay, and we get our a's results as 2. So just like this, you get to your final results. So personally, I prefer to use this point, but you should be able to get the results as well, even if you substituted a different point here. So that's all for your question 4. Okay. Moving on, we have our question 5 here. Okay, a geometric progression. So they specifically mentioned that the 5th term is 8k, the 6th term is -12, and the 7th term is 2k. So about this, right, when there's one thing you need to know, if they give you variables that is close to each other, usually you can use this to identify the common ratio here, that U5 is actually AR4, AR5 and AR6 respectively. So when you divide them against each other, for example, your U7 against U6, you will get R, while when you take U6 divided by U5, you will get R as well. Then from there, we might be able to trace our results. So when I take 2k divided by -12, it should be equals to when I take -12 divided with 8k here. So when we rearrange them, or should I say cross multiply, you should have a 16k squared equals to 12 times 12 is 144 if not mistaken. Okay, notice that the negative is gone because negative times negative, so k value will actually be square root of 144 over 60. So they mentioned that k is negative. Okay, so this is the key information here. They specifically mentioned that k is negative. So the k that we gotten will be this, which is -3 log. From here onwards, what you gotten was k only, but we still don't have our r and a's value. So when you sub in r equals to u7 over u6, it should be 2 negative 3 over negative 12. The answer of this should be, so r is 1 over 2, then from here we identify our a. Our a r5 equals to negative 12. A will actually be negative 12 divided by 1 over 2 to the power of 5. And you should get your results as negative 384. So from these two values that we gotten, okay, and then we try to trace our S infinity is actually a of negative 384, 1 minus 1 over 2. So your final answer for this would actually be negative 760. So that's how you secure the 4 marks here for question 5. Moving on, we have our question 6 here. The equation of the curve, okay, is this, where k is a constant, the line is y equals to 3x minus 4. It's a tangent to the curve. Okay, these two things, set them up equals to each other and then run the rearrangement first. So you have 2k minus 3x squared minus kx minus k minus 2 equals to 3x minus 4. When you rearrange them and make them equals to each other, okay, there's a few things that I did here. First of all is this negative multiply into the brackets, and I carried the 3x and negative 4 to here. So positive 3x becomes negative 3x, negative 4 becomes positive 4. So from here, rearrange it, okay, reorganize everything. There's one thing that I would do is I would put a plus there, and then I put negative k and negative 3 inside of the brackets. So by doing so, my a, b, c's value will be as accurate as possible. And then we have a 6 minus k at the back. So just put it like this. Now everything is much more organized. And from here, we can trace our k's value by using b squared minus 4ac. Okay, so from this, here your b squared is referring to negative k, negative 3. Our 4 is actually 2k minus 3 followed by 6 minus k, and make it equals to 0. So you actually get k squared. Okay, let me readjust them. K squared and then plus 6k plus 9 negative, okay, put it as 4, 2k becomes 12k minus 2k squared plus 3k. So last but not least, multiply the negative 4 into it. And then you will get to your results here, that is 9k squared and you have a 54k and 81 at the back. So from this, factorize it up, you will get 9, you get negative 54, you get 81, and you have your case value as this. So it's basically the same thing. K will be 3 at the end. So that's how you find this case value here of this question. Okay, quite easy, I would say. Okay, so long that you took admits back then and your foundation for your algebra is very good. Okay. Question 7. Okay, they ask you to prove this identity here. Okay, 2 marks only, so it shouldn't be too hard. Since they wanted tangent square at the back, it should be related to our sine over cosine. So a couple of things that will be changing is the 1 and this here. Okay, there's a lot of alternative solution. It's up to you what you want to use. They didn't specifically restrict you on this. Okay, so personally I identified that the 1 can be written as sine square theta plus cos square theta minus 2 sine square theta. And the other thing is that the denominator here can be written as cos square theta. So when we run the calculation, you actually get cos square theta minus sine square theta over cos square theta. So from this here, you can then split them up like a normal fraction. And this is what you should be getting. Further rearrange it, you will get 1 minus tangent square theta, which is what the question is looking for here. So this is how you solve this question 7a. 2 marks, not really that hard. So by transferring the information from part 1 down, okay, we noticed that it was 1 minus tangent square theta equals to 2 tangent 4 theta. Okay, so to make your life easier, I will be setting tangent square theta as y. Okay, so by doing so, you actually have this and then a 2y squared. Reason behind, I'll write it over here. So this thing here can be written as tangent square theta, and then there's a square outside of it. So that's how you make everything into simpler form where you can run the calculation much easier. So from here it's a quadratic again, okay, and then through this calculation you get your y plus 1 as well as 2y minus 1. So let me double check. Yes, this should be correct. So you get y equals to 1 at the end of the day, okay, negative 1 to be precise, and y will be 1 over 2. But kindly take note, what we are looking for here is not y itself, but our tangent theta. Okay, so when you try to square root a negative result, you actually get math error for this. So this is why this here will be irrelevant. Okay, so I just put not acceptable. Okay, so there's no calculation needed on that side. But for this, when you get rid of the square there, it becomes a square root. Okay, which you have plus minus results basically. So our tangent, when you draw out the quadrant, okay, it is from 0 to 180 specifically. So our first result of positive 1 will be right over here, while the negative 1 will get us the results on the other side, which is this. So when you split up the calculation, you will get your tangent inverse, square root 1 over 2, as Okay, make sure you change it back into degree mode. It is actually 35.3 degree. Okay, and for the other one, when you key in a negative at the front, you will get a negative result, negative 35.3. However, because of our range here, there's no negative, so it cannot be accepted. The negative is actually somewhere here, where you can reflect it to the other side and do something like this. So to get to the results here, we'll be taking 180 minus 35.3. Which is 144.7 as your final answer here. So these two will be your final results. Okay, so that's how you trace the answer for this type of trigonometry question. Moving on, we have another question that goes by radian. Okay, all of the corners of this is actually 4 centimeters. So I notice it by reading this statement here, which help it qualifies as a equilateral triangle. So this triangle basically repeated twice. Okay, for equilateral triangle is basically 180 divided by 3, which is about 60 degree. But since they wanted us to write it in radian mode, okay, this 60, when I multiply with pi and 180, you will get to your results of pi over 3. Okay, so with this pi over 3 here, what you can do next is basically, you know, these two values is pi over 3 already. So a full circle is actually 2 pi. Okay, when you minus off pi over 3 and pi over 3 twice, divided by 2, then you will get 2 pi over 3. Okay, so this is what I would write down to show this. Okay, and also aside from this, to support my statement here, I can write down PC equals to PQ equals to CQ, okay, equals to 4 centimeters. This is an equilateral triangle. SC equals to SR equals to CR equals to 4 centimeters as well. Same thing, it is also an equilateral triangle. Okay, equilateral triangle will have a 60 degree times pi over 180 equals to pi over 3. So to calculate PCS, okay, you will get the results here. If you want to further clarify to the examiner, you can write PCS equals to QCR. Then you need to do the calculation at the side. That's how you will get to your final results here. So the exact perimeter of the plate. So there's a few things that I'll be calculating. First will be these two sides here. So since they are the same, I'll be using this formula here. And our radian was 2 over 3 pi times with 4 centimeters, and that's 2 of it. On the other hand, we actually have 2 blue ones, which is here and here. So this one here is actually the same thing as well. They specifically mentioned to us it was actually a PQ was 4, which means half of it will be the radius 2. Okay, so pi, okay, semicircle is basically pi because 180 degree. Multiply with 2, then you will get to the results here. So let's run the calculation. 2 over 3 pi times 2 times 4 plus 4 pi. You should get your answers as 28 over 3 pi at the end of the day. Okay, that's how you identify these 3 marks here. Not much, but mainly is whether you have the patience to read the question truly or not. Okay, so moving on to part C here. Okay, I just analyzed the shape again. So if I were to redraw this entire thing, it will look something like this. So there's a full circle, okay, and they mentioned that there is 2 semicircles that they removed from the shape. Okay, and the area of the plate, okay, most of the students might miss out on this particular part at the top, at the bottom. Okay, this is the part that might throw you off guard of your entire calculation here. So we have no choice but to calculate the details first. So if I were you, this is what I would do. I'll be focusing on identifying the shaded part first, because the rest is quite straightforward. Okay, the rest of the formulas goes by, first of all, we have a full circle here. That goes by this. Okay, this is actually the red full circle. Okay, and then we will be minusing it off with our small circle over there, the blue one. Okay, since it's a semicircle, when you attach them up, it becomes a full circle again. So the same formula, but just a slight difference in the radius. Okay, and then will be the 2 parts, okay, which we always, students might forgot about it. The 2 sectors here. So I'll put a 2 at the front, so that I only have to include one of them for the calculation. So the details is over here. To get to the answer, we need to take the sector itself, okay, minus off with the triangle. Okay, the triangle is the red one that I drew there. So first of all, it is actually 1 over 2 times with our pi over 3. This is what we identified earlier, the 60 degree there. And then multiply with 4 centimeters square. Okay, with this, you minus it off with half AB sine C. Half times 4 times 4 times sine pi over 3. So let's run the calculation and see what do we get. 0.5 times pi over 3 times 4 square minus off with 0.5 times 16 times sine pi over 4. So one thing to take note, this is in radian mode. So we actually get 8 over 3 pi minus 4 square root 2 for 1 of it. Okay, so for 2 of it, so fill it up first. Okay, fill it up. Let's run our calculation. 0.5 times 2 times 16. We get 16 pi here minus 4 pi minus 16 over 3 pi plus 8 square root 2. Okay, let me double check on our calculation at the top. 0.5 times 16 times sine pi over 3. Oh, it's a square root 3. I accidentally written it as square root 2. No wonder. Okay, so from here, 16 minus 4 minus 16 over 3. So I'll get 20 over 3 pi plus 8 square root 3. So this is how you get your final answer. So most importantly is how you break down and dissect the graph. So if you were to take it as an entire circle and then just minus off the semicircle that was there, it wouldn't justify the 5 marks that was awarded. Okay, the level of difficulty and the amount of working is not equal. So readjust it and you get your final answer from this. So question 9 here, they mentioned that x must be specifically x more than equals to 2. So when I substitute this 2 into the calculation, okay, you will get your results as -4. So what this indicates is that for our f here, it will always be more than equals to -4. So that's how you trace the results here. Okay, when they gave you specific figures, the best way to do it is just to substitute it in. And to find f inverse, okay, so just follow the steps that I used back then. Y equals to x minus 2 squared minus 4, swap them up, rearranged it and make it the subject. Get rid of the 2 and you will get to your final answer here as your f inverse x equals to square root x plus 4 plus 2. So make sure you put the 2 away from this search there to avoid any confusions. Given that a is -5/3, solve the equation here. Okay, so let's give it a try. They say that x minus 2 squared minus 4 equals to -5/3 x plus 2. Readjust this. X squared, okay, -4 plus 5/3, you will get -7/3x minus 2 equals to 0. Substitute into your calculator, so we got -7/3 and then -2 here. Oops, forgotten to put in the figures. So your x value will actually be 3x plus 2 followed by x minus 3. So your x could be -2/3 and x equals to 3. So you have to check from the range that they gave us early on. They say that x must be equals to 2 or more than 2. So over here, this one is not acceptable. So only results will be x equals to 3. So always when you check, make sure you refer back to the range that was given to us. Okay, so this is how you solve the ABC over here, and we have one last thing, which is to identify our D's value. So they specifically put G, okay, and then there is a G, and then there is a F inverse 12 inside of it. Okay, interesting. And it is equals to 62. So if I were you, I would solve the F inverse 12 first. F inverse was this. Okay, let me write down the calculation. This actually goes by 12 plus 4 plus 2. So from here you will get your answers as 16 is 4, 4 is 6. So now what you have left is this. So G6 is actually, how much was A there? 6A plus 2. Okay. 6A plus 2. So we have G 6A plus 2 equals to 62. squared plus 2a plus 2. When you readjust it, it becomes 6a squared plus 2a minus 60. So try to trace these results here. 6 to negative 60. See whether we can get the results or not. You will actually get 3a plus 10 as well as a minus 3. So a could be negative 10 over 3 and a can be 3. So these are the two results that I identified from the function calculation here. So make sure you do all the works on the side, then you can secure the full marks. Okay, moving on, we are at question 10 now. Okay, this is actually the last few questions that we have here. Okay, let's have a look at it. So they say x squared plus y squared minus 4x plus 6y minus 77. Find the x coordinates of point A where the circle intersect at the x-axis. So the key word here is actually intersect at the x-axis. When they intersect at the x-axis, your y will automatically become 0. So when your y is 0, so you have 0 squared minus 4x plus 6 times 0 minus 77 equals to 0. We adjusted everything and you will have this as your final results. Okay, so when we sub in accordingly, okay, 1, negative 4, negative 77, you will get your answers as x either is 7 as well as it is 11 here. So this will be your full answers that we identify. Find the point of intersection of the tangent of the circle at A and B. So for part B, I personally would do something extra here, which is to identify the center of the circle using readjusting the circle equation that was given to us. So this one actually involved a little bit of completing the square concept. Okay, so how it works is you're required to run some calculation here. So you actually x squared minus 4x y squared plus 6y and then minus 77 equals to 0. So if I were to complete the square here, I would actually get the results of x minus 2 squared plus y plus 3 squared. So we have negative 77, we have to minus off what we added in on both sides here. So x minus 2 square plus y minus 3 square, negative 77 minus 4 minus 9, you will get it as 90. So when I shift away the 90, it becomes positive. So this is how we get the equation at first. And then they wanted us to calculate the tangent here. So from this, I know the center of the circle is actually 2 and negative 3. You get it by running this calculation at the side. Okay, this is how you get it done. Okay, so once we're done identifying the center of a circle, okay, I find it better if I illustrate it out to show you what does it means. So for example, this is the circle, this is the point, it is located at 2, negative 3. this point here is 2, negative 3. And then from the top, we identified that the intersection was at negative 7 as well as 11. So basically, it could be a line over here. Okay, and then this is your negative 7. And this is your 11 here. So the point of the intersection tangent to the circle is referring to, for example, if you draw a line and a line here, they want you to look for this intersection. Okay, so to get to that, we need to identify the gradient of this center against this 2 points first. Okay, so let's work out the calculation. So find the gradient of, let's say this is A, this is C, A and B, this is your C here. MAC is actually negative 3, 0 over 2 minus 7. So let's see what's the answers that we gotten. So it's actually negative 1 over 3, while your gradient of BC here is actually negative 3, okay, minus 0 as well, and then we have 2 minus 11. So we have 1 over 3 here. So with this gradient that we identified, we can now trace the value of it by doing, okay, what we identified was here, and the blue line that we need is actually perpendicular to it. So there's a 90-degree here basically on both sides. So you have A gradient is actually negative 1. So negative 1 divided with negative 1 over 3, you will get the answers as 3. And your B gradient is actually negative 1 divided with 1 over 3, you will get negative 3 for it. So with these two results, when you try to identify their respective equation, you will get the answers as y equals to 3x plus c. Since our y was 0 at the point, okay, 3 times negative 7 plus c will be 21. While your b tangent equation is y equals to negative 3x plus c. The point was 11 and 0. So your c's final answer will be 33. So when you put these two equations equals to each other, then you'll be able to identify your final results. So I write it down somewhere around here, where you have 3x plus 21 equals to negative 3x minus 8 plus 33. So 6x equals to 33 minus 21. You will get it as 12. X will be 2. So they were looking for the point of intersection. So if this 2 is not enough, you need to sub in 2 into either one of the equation, B tangent equation. Then you get your results as y equals to negative 3, 2 plus 33. So from this, you will get your results as 27. So the 2 point of intersection over 27. So the details here is quite lengthy. So let's do a quick recap here. First of all, I identified the center of the circle. Okay, that's actually over here. Okay, because with this center of the circle, I can trace the gradient from it. Okay, I illustrate this out next to help you to identify what we are currently dealing with. So I then move on to identify the gradient of AC and BC. Okay, and then because they are perpendicular against the tangent line, okay, that will be our -1 divided with their respective gradient. I get 3 and -3. Substituting the respective x to identify their full equation, which I get one of the c is 21 and the other c is 33. Then from there, put the equation equals to each other, then you identify the point of intersection. Alternatively, you can use your dy dx to do so, but personally, I prefer this method here. Okay, there's no right or wrong, you can choose whatever you want to do. Okay, so moving on, we have our last question here, which is question 11. They ask us to identify the normal to the curve. Okay, so the first thing that I will be doing is, for our normal equation, it goes by fa minus 1 over f prime a, and then x minus a. Okay, this is the formula that I always use. Fa is actually referring to the y that was given to us. F prime a is actually the dy dx, and a here is actually the point that was given to us. Okay, the x point. Okay, that's how I identify it. So when I sub in my f as 4, okay, it will be this. Okay, calculate the results. 2 square root and then minus 4 from it, you will get your results as 4. As for your f prime, which is your dy dx here, we still have to work it out. So I will first update our equation as this. Okay, and then when I differentiate this thing here, okay, first thing first, bring out the power, copy back the brackets, decrease the power by 1, and then differentiate the value inside the brackets. As for the x at the back, it's actually only power of 1, so the result of that will be 1 only. So after the entire readjustment, you will actually get to this. Okay, remember to add a negative there, and then minus 1. So when I substitute 4 into it accordingly, you will get this. Okay, key into the calculator to double check the results. And you will get it as -1 over 4. So with all this information that we collected, I can now construct my final answer. It will be 4, which I fill up from here, minus -1 over 4, which I get from here, and then x minus our 4 that was given to us. -1, -1 over 4, you actually get positive 4 here, and when you multiply it in, you get 4x minus 16 plus 4, which is 4x minus 12. So 4x minus 12 will be your final answer. So question 11 part B, they are asking for our stationary points here. So since we already did our dy dx, so just copy it down first. Okay, remember for stationary point, it is always referring to when your dy dx is equals to 0. So let me set it equals to 0 first, then you will have this. Okay, I transfer the -1 to the other side. Swap out the places. Square them up in order to get rid of the square here. And 3x equals to 5 because I transferred the 4. And x will be 5 over 3. But like I said, they were referring to the coordinates, so you still have to find out what's the value of your y. So you have to substitute in your x equals to 5 over 3 into the equation. So your y will be 2 square root 3 5 over 3 minus a plus 4 minus 5 over 3. So it's 6 minus 5 over 3, you will get your results as 13 over 3 here. So that's how you solve your y equals to 13 over 3. So the full coordinates goes by 5 over 3, 13 over 3. Okay. Moving on to the next part, determine the nature of the stationary points. So from what we gotten here, you need to identify your d2y dx2. So you have to repeat the steps again, multiply with the existing power, 3x plus 4, and then minus the power by 1 again, and then differentiate the value inside the brackets. The 1 that was from dy dx will be cancelled because it's an integer's value. So from here, when we calculate the details, you will get -9 over 2, 3x plus 4, -3 over 2 as your final d2y dx2's value. Okay, then we have one last thing to do, which is to substitute the 5 over 3 into it and determine whether it is more than 0 or lesser than 0. So we have -9 over 2, 3, 5 over 3 plus 4, -3 over 2. So let's key in this. And you will get your results as -1 over 6. So since your d2y dx2 is lesser than 0, means it's a local maximum. Hence the point is maximum. Okay, so this is how you get C done here. And to find the exact area bounded by the curve of the x-axis, 0 to 4. So they were asking you to calculate this. So the curve equation goes by 2 square root 3x plus 4 minus x. 2 square root 3x plus 4 minus x. So let's run our calculation here and get our final results. Okay, if I were you, I would be separating them up. The results at the back, you will get it very fast. Okay, because it is pretty straightforward. You will actually get -1 over 2 x squared for it. So just in case, I will show you the details calculation at the side. So like I said, your dy dx is currently -x1. The y of it will be unknown, x squared. When you differentiate it, you will have two unknown x, and when you compare them accordingly, your two unknown against -1, unknown will be -1/2. So this is the reason why I put -1/2 here. As for the other one at the front, okay, this one is slightly trickier. So I repeat the same thing at the side. dy dx equals to 3x plus 4 to the power of 1/2. The y of it, okay, I put it unknown at the front first. Value inside the bracket will never be changed, but the power will increase. The power will be increased by 1, which arrive at 3/2, and when we try to differentiate this, it's where it gets slightly messy here. Okay, students always forget to differentiate the brackets. You actually have an additional 3 inside. So this is the final outcome of it, and when you compare it accordingly against the 2, you will know that 9/2 unknown equals to 2. Unknown will be 2 divided by 9/2. You will get your answers as 4/9. So write this thing down. You will get your answer as 3x plus 4 and then 3/2. Substitute the 4 and 0 into it, then you will get your respective answers. Okay, adding up with the same thing. Okay, so from this, you will get to your final answer lah. So your final answer of this would actually be 152/9, or it will be 16, okay, minus 16. So this will be 8/9. Okay. So that's how you solve this question entirely, to find the area bounded by the curve between 0 to 4. So that's pretty much it for this paper. Okay, so I hope you find this video helpful, and I wish you all the best in your upcoming examination. Overall, this paper is actually considered quite easy because the main assessment here is all the concept that you learned back then in advanced, except for this circle part, which I find it slightly troublesome because you need to identify the center of the circle first for the method that I always use. Okay, and the rest is pretty much identical to what you have learned back then. So I hope you find this video helpful. Okay, if you have friends that are struggling, feel free to share this to them. Bye bye.